Yeah, hello. Good evening, everyone. Am I audible?
Yes, sir.
Thank you.
Yes, sir.
So, this is the last class of this course. So, I hope you have gone through all the lectures. Have you? Yes, no?
Yes, sir.
Yes,
Okay. So, when is your exam?
the Sunday,
20 March.
This coming Sunday,
this
26th.
Sunday, 26.
Okay. Okay, then good luck for your exam as well.
Yes.
So, this is the week 8 discussion on solar photovoltaic principal technology and materials. So, this is the course which is being taken by Professor Ashish Garg from IIT Kanpur, and I am Ravi Kumar, a PMRF research scholar at IIT Bombay. So first we will recap what we have learned in this class or in this course. So we started with solar radiation on earth and all. Then we move to materials, semiconductor, then after this we move to PN junction type semiconductor. Then we went to this solar cell, and then different generations of solar cell. And this is the last class which ends with the third generation of solar cell. So can you just tell me what are the three different generations? First, second and third. Can you name them? You can write in the chat box as well, or you can speak. It's your choice. First generation, which technology is? Second generation, which technology? Third generation, which technology?
So first generation monocrystalline, polycrystalline.
Yeah, so we can say
Silicon.
crystalline silicon. Crystalline silicon. Second generation,
Then amorphous silicon, thin film.
yes, that is thin film. And third generation,
Then organic, perovskite, quantum dot.
yes, organic and all. So, have you seen solar module around you? Like, have you seen these solar technology in the field near your home, near your college, near your workplace, anywhere? No.
I have seen module.
What
Yes,
was?
yes. I'm asking about module only. You have seen module, right?
Yes, sir.
Okay. So, what kind of module that was? Like, can you just tell me what it was
So
like?
it was polycrystalline.
Polycrystalline. Okay. Then how you are sure like it was not mono, it was poly?
So structure and it was blue in color.
Blue in color is because of ARC, anti-reflective coating. So it will be in all modules.
Okay.
Do you know the shape of cell? Just remember how a solar cell being built using silicon. So I told you ingots, and second one was just settling down the silicon. So based on the shape we can say which module having monocrystalline silicon cells and which module having multicrystalline silicon cells. Have you seen thin films near you? No.
No, sir.
Okay. So I will just want to tell you, if this is a solar module and like cells are like this, somewhat rounded in shape. Like this. And another module is like this. Perfect square rectangle. So did you observe any difference in field? Did you observe these cells as well as these cells? I'm not in my lab, even I can show you, but currently I'm in my room, so I don't have any solar module in my room. So I told you we have a ingots like circular one. So this is somewhat like this ingots, and for this case we having a rectangular piece of silicon. So if we cut this part like this, so which shape we will get?
Square shape.
Square shape. And if we cut this shape, so what shape we will get? Circle.
Circular.
Circle. So here we are getting circular shape, here we are getting somewhat rectangular. So this is our polycrystalline and this is our monocrystalline. But to save the space, what we do, we just cut the corners. So what shape we get? We generally get, if this is a circle, then we just cut it as like this. Bigger one. So this shape will be like 1, 2, 3, 4, somewhat circular, 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 circular. So these cells are monocrystalline and these cells are polycrystalline. So next time when you find any module nearby you, you can see and you can just guess which type of technology is that. It is monocrystalline or silicon crystalline. Second question. Yes, second question I'm having from you is that if we are having a module like this and these are the cells 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and let's say area of cell is 100 centimeter square and number of cells are 10. Can you guess the VOC of module and ISC of module? And can you guess PMPP? How much power it will generate? Just by seeing the module. By just seeing the
The connection matters.
Yeah, connection.
Series of panels.
All connections are in series. It's like this is the output. positive, negative. Now, and these are say multicrystalline or polycrystalline. Just see if you can.
So 5 volt VOC.
You are saying 5 volt VOC. Okay.
I don't have idea about ISC.
Okay. So let me give you one thing. For the crystalline silicon module, we usually take J equals to 0.035 ampere per centimeter square. So this is the current density by a crystalline silicon cell. Means per centimeter square it is generating 35 milliampere current. Now
35 ampere.
35 ampere.
Yes. Mm, no, the 3.5 ampere.
3.5 ampere by one cell. So if this cell is having current 3.5 ampere and all cells are in series, so current will be
Same.
same, 3.5 ampere. Okay, now I told you PMPP. So PMPP generally what? PMPP equals to fill factor into VOC into ISC, and generally fill factor is around 0.8. 0.8 into 5 into 3.5. This will be the power of this module. Just calculate.
$14.
Yes, 40. So by just seeing the module, you can guess the power of a module.
Sir, why POC is 5 volt is given?
It's no. It's actually VOC comes from band gap, and generally band gap is 0.56 for multicrystalline silicon cell. So it should be like 0.56 for one cell, and there are 10 cells, so it will be 5.6 volt.
Okay.
Yes. So more accurately, we can say 5.6 into 3.5 into 0.8. It's 15.6 watt. More accurately, it is 15.6 watt. You got it? Any confusion
Yes,
here?
sir.
Yes.
Yes means confusion or not?
No, sir. Focus.
Okay. Okay, that's fine. Okay, so this was the recap. We started with solar radiation, and today we have seen different technologies of solar photovoltaics. So just see once again solar technology, what we have: first generation, second generation, third generation, and fourth upcoming generation. In the first generation, we have like crystalline cells, and the efficiency is given here. The more accuracy is 45 for multi-junction solar cells from the third generation. These are the thin films, and these are the crystalline, and these are the, we can say, organic or DSSC. There are so many dye sensitized, and this is the upcoming technology, hybrid. Means they will combine one or two generation So same thing, we will see advantages and disadvantages from each generation. So in the first say, we can say for the crystalline silicon solar cells, they have high carrier mobility and it is a mature technology which is currently installed in the field. And disadvantage is it's like costly, cost comes from wafer silicon purification and its loss of photon energy because the absorption is not good in crystalline silicon solar cells. Second, we have like thin film technology. In this we have amorphous silicon, CIGS and cadmium telluride. They are less expensive, they have lower efficiency as well as plus. Do you know about anything about cadmium? Is it good for our health?
Toxic.
It's toxic substance.
Toxic.
Yes. And here silicon is just a sand dust. So even we can recover it, and if this goes into the underground water, means after the life of module, then it will contaminate our groundwater. And also there are other challenges in, we can say, recovery of these substances, because it is having only 1 micron meter, we can say 0.1 to 1 micrometer, and here it is 100 micrometer depth, or we can say the, yes. And third generation, it is mostly it is in the lab only, and they are having like low production cost, comparable efficiency, but they are not stable. And also it is an immature technology. What is the means of mature technology and immature technology? Here just we are seeing silicon is mature technology, but it is immature technology. What is the difference? What do you think about this? Any guess?
Sir, silicon is actually high temperature based process.
Okay, I just want to ask you a question. If you want to buy a new mobile, and there are so many companies available in the market, and just few days back a new companies come and they are selling their mobile, so how will you buy? Will you buy it? Yes, no? If yes, then why? It means new mobile technology, you don't know anything about the company, it's completely new to you. How do you buy anything? If you want to buy anything, let's say mobile is the common need, so we can say if you want to buy a mobile, so how you go about it? Other than your requirement, what do you see?
So company's background.
Okay, so what about reviews? You go with reviews? Yes, no?
Yes, reviews.
Yes, sir.
So what is the reviews? What reviews told us? Reviews are telling us what?
Efficiencies.
Efficiency, yes.
Work.
Yes. Generally, what happen?
Quality.
Quality, yes.
Experience with people. Even.
Yes. The main important term is the reliability. Reliability is the most important thing. What do you understand by the reliability? Sometimes what happens, we having a mobile with good battery life, everything is good, but within 2 weeks it goes, like it become dead. Then it is a good or not? Is it good?
No, sir.
No. So in that case, reliability is the most important thing. So if we say they are mature technology, means they are reliable. If we say they are immature technology, they are not reliable. And now I'll tell you the meaning of reliability. It is the, say, probability of doing or performing a particular or dedicated task for a suitable time under required conditions. So this is the probability, and there are 2 or 3 things. Like if we say using a mobile, I can access the internet, I can call anybody. This is the task which is being performed by the mobile. And how long I can do it? It is talk about the time. And the main important thing is the under what condition. If I kept my mobile in 50 degrees Celsius temperature and I say to the company it is not working, will they accept it? No. So here let's come back to the solar technology. So these silicon solar cells have been tested in the field for a long time. They are working for a long time under the given condition. So the reliability has been established for crystalline silicon cells, which is not being established for these upcoming generations. So that's why we say silicon solar cells are mature technology as compared to others. Got it?
Yes, sir.
Okay. I think, yeah, I have a diagram as well. So this is the most important diagram you ever seen. It tells about the efficiency of solar cells with different time. You can see, first let's take the crystalline silicon cells. So this blue color is the crystalline silicon cells. So they started with around 14% efficiency, and today's they are having around 26% efficiency. And like these are the thin films. Even you can download this diagram in a good PDF from NREL website. This is the NREL organization, and this color, like green one, is showing thin film technology. It is first generation, it is second generation, and this is third generation, red one. This is based on the junctions. There may be combination of many technology, but they are having different junctions. Like we can say we can have organic solar cell in the like lower layer, or in the upper layer we can have crystalline silicon solar cell. So these are those things. So that's why for the multi-junction solar cell we are having efficiency around 47 or 48%. That is the maximum. And theoretically, what we can have highest or maximum efficiency? Do you remember?
66
Not
for
66.
quantum dot.
No, 66 is being like they have got it. But I am asking theoretically, thermodynamically, what is the possible maximum efficiency? Okay, check it out. It's, I think, 76 or 86. Just check it.
Yes, sir, 86 for concentrated solar panels, something.
Okay, so in this lecture, we don't have much to discuss. We will discuss few questions, and these are the things we are discussing since the previous 2 weeks, I think. So if you have any doubt, you can ask, then I'll start with the questions. No? Okay, then I should start. So this is the first question, which says, which of the following are not true for organic semiconductor? And these are the options. Not true for organic semiconductor or solar cell, same thing. Let me know.
So they are indirect bandgap semiconductors. It's not true for organic semiconductors.
Okay, it means they are direct. We can say they are direct
Bandgap
bandgap.
semiconductors.
Okay. Other than that, do you have anything more?
So they have high exciton diffusion link.
Option B,
Do they have?
exciton diffusion link.
Am I right? Yes.
Yes, a low diffusion link.
Okay, Vaishnavi, you are also right. You are saying option A, but there are other option as well, option D. Okay, so A and D are the correct answer here. Let's go to the next question, which says, the band gap of CIGS can be tuned by, and these are the options. Tuned means, just let me know the meaning of tuned. Very okay. Vaishnavi A, Malade A. Okay, answer is right. It's indium gallium ratio. So what is the meaning of tune here? Band gap tune. It's like increase or decrease, or we can say get the desired value, or other thing we can say variable band gap. Yes, both you are right. This is the formula, and for easy, just putting the value of x, we can calculate the band gap. Yes, option A is the correct answer here. Next we have, which of the following is or are required for the exciton dissociation in single junction organic solar cell? If you understood this word, then it doesn't matter is it organic or anything else, you can do it. What is the meaning of excitance dissociation?
It's an ionizing.
Sir, break the electron for pair.
Yes, more appropriate is the breaking down or separating, we can say. Dissociate is breaking something, associate is like adding something. Okay, these are the options.
Sir, A and C.
Presence of interfaces.
C.
Okay, Vaishnavi is also right, A and C, and you are also right, A and C. Yes, both are correct, A and C. Okay, next question. It says the p-type character of CIGS is attributed to the following option. Among these, which material or which element is used for giving p-type character to CIGS solar cells? Okay, Vaishnavi saying A.
Sir, A, sir, copper vacancies.
Yes, both of you are right. It's A. Copper vacancies. Copper vacancies. Okay, so this is the next question, which says the reason for using soda lime glass as substrate in the fabrication of like CIGS solar cells are. Okay, do you know what is the role of what is the role of this soda lime glass in solar cell? Any solar cell, solar module, sorry, I'm saying solar cell, it's about solar module. What is the role of soda lime glass in solar module? Do you know the component of solar module? We studied in this course about solar cell, but the next part comes solar module. Even if you will see anywhere nearby you, you will see a solar module. You will not be able to see solar cells or bare solar cell, we can say more appropriately. You will see only solar module. Okay, first let's do this question. I'll talk about solar module after this. So it is saying the reason for using soda lime glass as substrate in fabrication of CIGS cell is B and C. Vaishnavi is saying B and C. Defects, it doesn't mean because it is the lower layer, so it is not, it doesn't take part in defect and all. And sodium is not being used for the connection or for the element or for the charge separation or collection, so it is not used, it is not having any part in series resistance. Yes, you are right, Vaishnavi, it's B and C. B and C. Okay, next question, it says which of the following defect is responsible for increased carrier recombination in crystalline or CIGS solar cells. And these
Copper
are,
NAD.
sorry,
Copper, vanadium.
you are saying copper atom substituting indium sites.
Yes, yes.
Copper atom substituting indium sites. Yes, Vaishnavi is also saying same. She is also saying copper atom substituting indium sites. Yes, B is the right answer. Next question, which of the following is true for organic semiconductor? Same question as it was in the first one, but something is different here. It like very slightly change. With this slight change, this is the same question as it was in the first.
A and C.
They are direct band. They have high binding energy.
C. I. A and C.
Okay. A and C. What about B?
B also right answer, sir.
Yes, B is also right here. So A, B and C. Yes, correct answer will be A, B, C. Okay, next question. It says the semiconducting behavior of organic semiconductor is attributed to. And these are the options. I hope you got the question, because generally organic substance are insulator, but they are having character or semiconducting character. So it is asking the reason behind it.
So B and D.
B and A.
B and D.
B and D. Yes.
But
Because
sir, I have one question, sir. Sir, organic semiconductor is naturally benzene ring. Then in benzene ring, when substitute sulfur atom, then we put the organic semiconductor. Do. But why not benzene ring is correct? Sir, firstly, atom is form of benzene ring. Okay, sir. In benzene ring, we have a dope with sulfur. Then we prepare organic semiconductor.
but
Pi to delocalize pi electrons.
yeah, but you are
Then why not benzene ring?
yes, you are telling the thing. If we are doping the benzene ring, then it is becoming semiconductor, right?
Yes, sir.
But it alone, it's like standalone benzene ring. If it is present without any doping, it is not a semiconductor, right?
Yes, yes.
So this
Yes,
is
sir.
the same thing here. It is saying if we are not doping anything and we have only benzene ring, will it be a semiconductor?
No, sir.
No. That's why it
Pi
is.
electrons are not.
Yes.
Yes, sir. But
So B and D. Vaishnavi also told B and D. Both are right. B and D. Okay. So these were the questions. Now I'll talk about a bit about module. If you want. You want me? Okay. See. If this is a solar cell. These are the so many solar cells. Then we have a layer here. And we have a layer here. And above this we have another layer here. And we have, this is a thick one. And this is the transparent one. So these are EVA. or we can say encapsulant, and these are transparent. This is white in color. This is back seat, and this is our soda lime glass, and this is the cell, solar cells with ARC. So this is the basic structure of a module. So what is the property or what is the role of everything, we will see. See, if this is a cell, it is very fragile in nature, and if we are carrying it like this and we are just holding from its one end, then it will break, because the thickness is not that much high and it is silicon crystalline, so that's why it is very fragile. So in order to keep it safe, we need to encapsulate, or in general word we can say we need to laminate this. So we need to laminate this solar cell with some safety elements, and in those safety elements we are having EVA, encapsulant, backseat, and soda lime glass. So here everything, like these all are things mechanically weak, and this is mechanically strong. So the strength given to a module is given by soda lime glass. After that, if we are just putting a soda lime glass or just putting a solar cell on it, then it will be like it will not be encapsulated. So we need some kind of glue there, which will glue the solar cell on the glass. So we use this EVA. What EVA do? Our solar modules is being used where? It is being used outside. So outside we have rain, we have frost, mist, fog, we have wind. So these all are stressors. If we are having a glass, having two pieces of glass or having solar cell between them, and we are putting in the field, if water goes inside the solar cell, then it will harm our solar cell. That's why we are using EVA. So this, what EVA will do, it prevent water ingress, plus it bind solar cells with glass and backseat. So that is the role of this EVA. And other than that, we have backseat. It is an insulator with high resistivity, because if we are having a series, or if we are having so many modules in a string, then it can give us a electrical shock to the person if anybody will touch the solar module. That's why in the backside area we are using a backside. It is a polymer. It is a polymer which is insulator in nature, having high resistivity. So these are the components of a solar module. Next time, whenever you get a chance to see a solar module, just see carefully, like if this is a frame and this is a like junction box, you will see some EVA will be there outside, some EVA will be there. So you will be able to see where is the EVA, where is the back seat, where is the cell, where is the glass, and where is this solar cell, and where is this junction box. So next time if you get a chance to see a solar module, then identify all these terms and then see, and also just try to remember the role of these components and see are actually they are performing their work or not.
Okay, sir.
Yeah.
Sir, I have a doubt.
Yes.
Sir, I saw a soda lime glass placed in the bottom layer when a lecture was going on, but here you said it is in the top layer.
Okay, let me do one more thing. Yes, you are absolutely right. So we are having two kind of structure nowadays: glass polymer and glass to glass. Why? If this is a solar cell, and if this is a PN junction, have you heard the word about bifacial solar module?
Sorry, sir.
Bifacial solar module, have you heard about this term? Bifacial solar module?
No, sir.
No. Generally we say this is monofacial, means light is coming from one side only, and this is known as bifacial. Light is coming from both the sides. So if this is a solar cell and if light is coming this like this only from one side, we will say it is monofacial. But if some light is also coming from back side, and rather than using back seat we are using glass, then it will increase the efficiency of solar cell. Because if this is a solar module like here, if it is a solar module and this is our ground and some light are coming directly, but some light will go here and it will reflect back, some light will go here and it will reflect back. So to capture this reflection, nowadays we are using glass to glass structure. That's why those modules you show or you are like you observe in your lecture or complex or all you are talking about, those are bifacial in nature.
Okay, sir.
Yeah. Any more question do you have?
No, sir.
Okay. So this was our last class and even content was not much. And if you have any general question about solar cell technology, about the reliability, about the structure, then you can ask.
Yes, sir. I have a question on in terms of exam related questions.
Okay.
Past 2 week lectures, I didn't get any numericals related questions in assignments. So is there any possibility for numerical related question in exams?
Yes. Like band gap of CIGS. This here we can make a numerical question and it will be very easy one. But there are not much questions from the last portion. When we started this generation part, we don't have much numerical questions after that. But
Okay.
one or two question only. It's like band gap of CIS. I think it is the only one which I observed during the lectures.
Yes, sir. It's just like before you calculated the band gap, that kind of questions only, no, sir?
Yeah.
Okay, sir.
Malade, I think they have corrected the solutions. You just wrote the mail, right?
Yes, sir.
Actually, there were some confusion or some. I don't think it was confusion or they are deliberately they are having wrong answer. So Malade just wrote the mail to them. I think they have corrected. Is he here, Malade?
Yes, sir.
Have your score have been updated in the
Sir, no, sir. Two questions still pending, sir.
okay, still pending. Okay, I think they are looking into
Two
it.
questions pending.
Yes, yes.
Okay, sir. Previously, sir, 1, 2, 3. Three questions they have updated the numbers also I did. Okay. Remaining two questions are pending, sir. Yesterday, I think 2 days
They
before I
replied
mailed.
back, right? They replied on that email.
Okay.
Yeah, they
This is
replied.
pending.
Yes, they will do it shortly.
Okay, sir.
So that's it.
Sir, I have one question.
Yeah. Yes,
Sir,
ask.
suppose I want to make one kilowatt solar plant. Okay, sir. So how many solar modules to be installed? How was it a calculation? It was 1 megawatt plant we have to install. Just a calculation. How many modules? There is specification.
See, I just want to tell you. I just visited. I just visited a company or factory which is like manufacturer of these solar modules. So nowadays, what they are providing a big module with a power, I think 540 watt. So if you will use two modules, then it will be 1 kilowatt. So it depends which module you are using. If you are using a smaller one, then you need to calculate the power. It's like DC to AC. Before DC, it is not much differ here. It's like 1 to 2%. If you are putting a 1000 or 1 kilowatt system here, so it will provide 1 kilowatt AC to you. It doesn't matter. So you need to calculate on this side, DC side. And DC side, how can you calculate? You just take a module, find out the power, and just multiply or divide 1 kilowatt divided by power of, wait, let me clear this. Yes,
Yes, sir.
it's like 1 kilowatt and it's the number of modules divided by power of module, and this power of module will depend on module structure. Module structure means number of cells plus area of each cell. And in market we have from I think 8 watt to 550 watt modules. You can use any module. It is just the number which will vary. Just think it or let me know. Just wait. Yes, yes. Yes, Baladev. Any confusion here? If you want to put one.
No, sir.
Yes, yes.
Sir,
Yes.
No, no conflict. Yes, understood.
Can you repeat? Like I'm not getting your voice was not clear. I understand. Okay. So do you want to put a system at your home? Yes. Any other doubt? Any book for solar technology from basic to advanced level, not only for this course but for higher studies. For the solar technology, or means solar technology are two kinds of technology: solar thermal and solar photovoltaics. In my opinion, the best thing for this solar photovoltaic is the pveducation.org website. Nothing can beat that website. They are having good animations, they are having good pictures or diagrams, everything is there. Yes, Sandeep, I think you are referring solar photovoltaic, right? For the solar thermal, case is different.
Yes, sir. Solar thermal also I am doing.
Yeah, it's a different.
Already a 12-week course. They are doing this course. Solar thermal.
So I think this is the last class, so we can have a small introduction what you guys are doing. As you know, I am a PhD research scholar at here IIT Bombay, and I am in third year of PhD. I'll be finishing my PhD in coming 2 years. And I am working in this photovoltaic field only. I am working on the reliabilities of crystalline silicon solar cells. So just your name, your place, and what you are doing.
So I am Moladev. Now I am working at Darshan Tukro at Tamil Nadu.
Okay. So Tamil Nadu is, I think, having good insolation.
No, sir. Actually, I am in distribution field, and now I am from distribution. I am working at OFC field, optical fiber. So I'm planning to shift my career to renewable. That's why I'm doing this course.
Okay.
After complete this one on solar thermal, knowing biomass, I will prepare my request transfer to renewable department. That's why I am doing this course.
Okay.
Photovoltaic and wind, biomass and solar thermal course.
Okay, that's great. Yes, Sandeep, you want to say something? I think my microphone is not. It's okay. You just write in the chat box. Student of MTech. Where? From which place you are? Optoelectronics. Okay, Raipur, Chhattisgarh, right? Yes, Sandeep, just ask. This is my second sem. Okay. at next I want to join internship in solar photovoltaics. Okay. Please suggest any college or professor. You can just contact. Just let me recall. There is a professor at MNIT Jaipur, Sunanda ma'am. You can contact her. I think she is having internship opportunity as well. Dr. Sunanda Sinha, MNIT Jaipur. If you are having a LinkedIn account, just search on the LinkedIn. You will get so many messages from the activity of the ma'am timeline. Even if you wish to continue or you want to go for PhD, then there is also a great option for you. Personally, I don't know Ashish Garg sir because he is from IIT Kanpur and I am from IIT Bombay. I just got this course by this IIT Madras. They are handling this NPTEL thing. I just applied and got this course. Personally, I don't know Ashish Garg sir. If you want to just know there are any internship opportunity and all, so there is another TA who will be taking class I think tomorrow or the day after tomorrow. He is from his lab only. So you can ask about Ashish Garg sir and in their lab, they having any opportunity in their lab. So they will be able to tell you. Is there any opportunity at IIT Bombay? In our lab, my professor is not having any opportunity of internship, but in another labs, I can look into it. You just do one thing, you just send me an email. I'll revert on that. So this is my email ID. So this is my email ID. You just send me an email because after this class, I won't be having any contact with you. So it will be better. Okay. So we know Sandeep Mala. So Vaishnavi, will you introduce yourself?
Yes, sir. Yeah, I am from Tamil Nadu, sir, and I am a postgraduate in physics student now pursuing in second semester going on, sir.
Second semester of postdoc?
Yes, post graduation in physics, sir.
Okay. Great. So which field you are?
It's physics only physics, sir. Major physics.
Major physics, but they are like high energy physics and all. Na? We have different branches of physics.
It's completely physics, sir. We study all the things.
So you study all the things like classical mechanics, electronics, thermodynamics,
yes, sir.
Everything.
Yes, sir.
Okay. Okay, then I think we are done for today. If you have any more question, then you can ask. I'm here.
Okay, sir. Thank you, sir.
Yes, Manaju. Thank you. and you were very active during all these lectures. Great.
Yes, it was good. I'm learning lots of things from this,
Yes,
and
yes.
that's why I became.
No, that's good thing. So best wishes for your future. Do good.
Yes,
Thank you,
actually,
sir.
sir, one thing I have noticed, sir, the way of explaining the physics is very, very. I am learning lots of from it. The
Oh,
basic things, suppose the variation of the band gap, then the effective temperature, step by step. That I never forgot it. The way of it. Technique is very good. Very
okay. Thank you.
yes, yes,
I just try to be
basics,
simpler
simple
because,
basics.
yeah, I just try to be simpler.
Yes, sir, yes, sir.
Yeah.
That's it. Thank you, sir.
Okay.
Yes, sir.
Best wishes from my side.
For your, yes, sir. Thank you, sir.
Yeah.
Sir, the questions is prepared by Ashish Garg, sir, or you three, sir?
No, no, no. I'm not preparing any question. My like job was
Okay,
just
sir.
to handle these interactions.
Okay, sir.
Yeah.
Okay, sir.
Yeah. Okay.
Next. Thank you.